Welcome back. So today I'll be discussing CodeChef March Long Challenge, Chef and a Beautiful Digit. So the problem statement says Chef has a decimal integer capital N and a non-zero decimal digit small d. N doesn't contain the digit 0, especially N should always be treated as a decimal integer without leading zeros. Chef likes d and does not like any other digit. So he decided to change and he may apply the following operation any number of times. Append a digit to the decimal representation of n, then remove one occurrence of one digit from the decimal representation of n. Chef has already changed a lot of numbers and he got bored. Now he wants to know the smallest possible value of n, which can be obtained by performing the above described operation. Can you help him? So the operation given here is that we are given a number n and a digit d. We need to find the smallest value of n by applying two operation basically. First of all, we will be appending the digit d to the last of the number n and then removing one occurrence of one digit at a time from the number. So let's look at the input. Input says we are given the first line will be containing t, the number of test cases, and the t lines will be containing two space integers, that is capital N and the value of small d. And output, in the output we need to print the minimum number chef can obtain. So let's look at the input given in the problem was t is 3 and the first input is 35 and the D is 4. Look at the output here. What we can do is remove 5 and append 4 at the last. So we will be getting the minimum value, that is 34. Here what we can do in the second test case is 42. So we can remove 4 and append digit 4 to the last. So the answer will be 24. And in the last test case which says 24 and the value of D is 9, as if we are replacing any digit and appending 9, the number we will be obtaining here is greater than 24, so we will be not performing any kind of operation and leave the number as it is, it is already the minimum number. So the explanation here tells the same thing I have told. Let's move forward and study, observe, observe a more complex number, how to obtain the smallest number from this. So what we are going to do here is, first of all, check the occurrence of all the number which are less than d starting from 1. If 1 is present, then we will be adding it to the smallest number. So we will be checking here is if 1 is present. Yes, 1 is present, so we'll append 1 to the smallest number. Now we'll be checking further if there is any occurrence of 1 after this one. So yes, it is here. So append it to the smallest number. Now let's move forward. Is there any occurrence of 1 left? No, there is not. So what we'll be doing is now checking for the occurrence of, first of all, now we'll be checking for occurrence of 2. Also 2 must be less than d. If 2 is less than d, then only we'll be going to check. If in here the value of d will be 2, then will not be checking further. But as we can see the value of d is 8, we will be going to check further. So if 2 is present, and also the condition is that will not be checking behind the one we have already checked. So it means that we'll be only checking the occurrence of 2 after the last one we have encountered. So is there any occurrence of 2 in this? Yes, it is here. So what we'll be doing is appending this 2. So after this, is there any occurrence of 2? No, it is not. So we'll be checking if the value of 3 is less than d, and as d is 8, so we'll be going to check for 3. We'll be not checking till here, we'll be checking after this. So is 3 present in this? Yes, it is present. So we'll be appending 3 in the smallest number. Now as we have reached the last, our smallest number will be containing these 4 digits, and now the will be appending D the number of times uh, this digit will be not be equal to the above digit, above number. So as we have already known that this number will the smallest number will be having 4 digits, but our original number was having 8 digits. Here you can see that above number was having 8 digits. So what we did here, we have appended 4 times 8. So this will give us our smallest number. Now let's move forward and look at the algorithm. So taking that example, we'll be designing the algorithm. Here we have taken a pointer max initially and declare it with 0. Now let's move forward. As I have already told you, we'll be checking for 1 to 9 as the digit lies between 1 to 9. So what we is doing is when I is equals to D break, so at this time it will be not be breaking as 1 is not equals to 9. So here comes n contains 1. Yes, it contains 1. So we'll find the first occurrence of 1 and the last occurrence of 1. First occurrence of 1 is at 0 and the last occurrence of 1 is at 4. So the last occurrence of 1 is at 4. So we'll be traversing from max is 0 until last. So we'll be traversing from 0 to 4, and if we got the value, we got here I in this n, so we'll be appending it here. So the value of max j will be 0. So is it equals to 1? Yes, it is. So we'll append 1. Now the value of j will be 1. Is this number equal to 1? No. Move ahead. Is this number equal to 1? No. Move ahead. Is this number equal to 1? No. Move ahead. When we will get to 4, this is 1. So again append 1, and now as we can see that j comes here, and which will be greater than the last. So this for loop will break and will change the value of max. So now we have already traversed in our loop till here, so we'll be traversing from this place. So the value of max is now being changed to let me change the value of max to the value of max will be changed to 4. Now let's look forward. Now the value of I becomes 2. Now in this array we'll be looking for the occurrence of 2. So as we know that the value of max is 4, and we first of all the condition here is I is equals to 2, 2 is equals to 9. No, it is not. So we'll be checking if this number contains 2. Yes, it is. So we'll come inside, and we'll find the occurrence. Here the first and last value will be 6 and 6. So we'll be starting our loop of j from max, and it will go on till last. So uh, j will be at 4. Is this number equals to 2? No, it's not. Move ahead. At 5, this value is not equals to 2. Move ahead. This value is equals to 2. So append it to the new string. So here we append it, and now the value of j becomes greater than last. So this for loop will terminate. Here we'll again update the value of max, and now the value of max becomes 6 and the value of I becomes 3. If here again this condition will be checked, and this condition is false, so we'll check if n contains 3. Yes, it contains 3. Here the value of first will be 7 and the value of last will be also be 7. Now we'll move ahead. and the value of j will start from 6 and go till 7. It will be pointing here. Is this value equals to 3? No, it's not. So we will not. We'll move ahead. Is this value equals to 3? Yes, it is. So the value of S becomes 1, 2, 1, 1, 2, 3. Now there, as we have reached the end, and this for loop will continue as this will not give us any kind of time limit exceed. So I have continued this for loop. Now it will go on for and for 5 and for 6 and for 7 and for 8, and when the value of I becomes 9, this loop will terminate, and here will print the value of s1, that is 1, 1, 2, 3. Here we have find the length of s1, that is 4, and we will repeat this for loop until it will be equals to the length of original number. So 4 is less than 8, so we will be printing 8 here 4 times. I hope you have understood the logic behind this. If you like this video, don't forget to like this video, and if you have any doubt you can comment in the comment section below, and don't forget to subscribe the channel.